Welcome to section 2.3. We're looking at function notation and making predictions. So to start off, we know y equals 3x plus 1 is a function. We looked at this in the previous sections. We can talk about it verbally. We could say if we plug in a value for x, multiply it by 3 and add 1, we get exactly one number. Alternatively, if we were to graph y equals 3x plus 1, we can start by doing the y-intercept 1, and then our slope is 3, so up 3 over 1. We get a line, essentially a vertical line. Whoops, hopefully yours is straight. And by looking at the graph, we know it's a function because it passes the vertical line test. Okay, so lots of reasons why we know it's a function. So we want to indicate that it's a function by replacing y with a function notation. So function notation is just a fancy way of writing y. So instead of writing y equals 3x plus 1, we keep the 3x plus 1, and we say that y is a function of x. Y equals f of x. And this is function notation. All right, so in this case, f is our function. And f is a function that takes our x and gives us a y value. All right, and then what we say f of x. So f, we say, so in quotes, f of x. All right, so there we go. Okay, so moving on, what we're going to do next is we're going to figure out how functions behave. So this is really an exploration part. So I would recommend pushing pause, doing this next few pages, and then pushing play, and we'll go over our solutions together. All right, so let's see how we did. So we're given a function written in function notation, and I highlighted the x's, and notice that's what we replaced in this next step. We put a heart in place of all the x's. Something similar down here in blue, all the x's in our g of x function I highlighted, and then replaced them with the happy face. Okay, and then finally the stuff that we're going to be seeing, not the kind of silly hearts and happy faces, are down here. So this is a function f of x. F of 2, we would say f of 2, you can write that as a note if you forgot, f of x, but now x is 2, so we would say f of 2. And all the x's got replaced with 2's. And now that's something we can actually calculate. So that's what this question asked us to do. And if we calculate it, we get that f of 2 is equal to 9. Okay, so 2 was our input, our x value, and 9 was our output, our y value. Okay, so that's really what our function notation does. Whatever we put inside our f of x, so f of a plus h, that's our input, and we have to plug it into our function. All right, so from there. So, let's see how you guys did with the graph. We have a graph of a function f. All right, so this could be considered your f function. And they give us some examples. They say f of negative 2 equals 4. So if we go to our function, f of negative 2, here's an input, and it's telling us the output. And then let's look at f of negative 1. Well, negative 1 is the input, it's the x value, and we're getting about 3.5. 0 is your input, 3 is your output. 0, 3. Okay, so the input corresponds to the x values, or the independent variable, and the output is all your y values or your f of x, and that's your dependent variable. Okay, so xy then, remember f of x is just a fancy name for y. So we're looking at something like this. So for instance, let's take this f of 2, negative 1. All right, so this is the generic, that's supposed to be an x. So now we're saying the input is 2. So x is 2. So your y-coordinate is f of 2. And f of 2 is negative 1. All right, so all of these things going on with our function notation. So it gets a little bit, it takes some time sometimes to get used to it. Okay, so let's practice this some more. And we're going to look at another graph. Use the graph to the right, answer the following questions. We want to find x when f of x is equal to negative 4 using the graph. All right, so sometimes until we get comfortable with the notation, remember f of x is just a fancy way to write y. Okay, so it's really find x when y equals negative 4. Well, here's y equals negative 4, so on the function that happens here and here. So we actually have two x values, x equals negative 2 and x equals positive 1. Whoops. Negative 2 and positive 1. Okay, so now we want to find f of negative 1. So now the input is negative 1. The input is negative 1. So this means x equals negative 1. So find the y value, the function value negative 1, or the function value when x is negative 1. So there's x equals negative 1, and on the function that corresponds to negative 2. So we would write f of negative 1 equals negative 2. Okay, so there you go. Let's see how this looks like on a table. So here's our function h. We want to find h of 2. So again, if we go back to our function notation, the stuff inside is our x values. So this means x equals 2. I'll draw an arrow. X equals 2. So when x equals 2, let's go to our chart. The corresponding h value is 4. So our answer, we could write h of 2 is 4. All right, and finally find x when h of x is 2. So again, until you get used to it, the notation, you can always write when y equals 2. All right, and y equals 2, I'll do it in green, happens in two places. H of x is 2 there and there. So what are the x values? 1 and 3. So we can write something like h of 1 equals 2. We could write that. And h of 3 equals 2. We can also write the answer as x equals 1 and 3. Something like that. All right, let's practice some more. Continuing on. So we have a couple of examples now to practice our function notation. This is a good time to push pause and then to come back and check your solutions. All right, so we're working with the same function. We're putting in different inputs. So if we look at part A, notice our input for part A, this is our function f of x. All right, so wherever we see an x, that's our input. So here the x was negative 3, so we replaced x with negative 3, and then simplified. For part B, x was 2, So we replaced x with 2 and simplified, etc., etc. Right? Even when it starts getting a little bit weird, like a over 2, it's the same process. We plug in the input and simplify. We have the input, we plug it in for x. Sometimes we need parentheses, and we simplify. Okay, so moving on, let's look at example 2. It's a little bit more complicated because we're dealing with squares and quotients. Let's do the same thing. Let's do example 2. Go ahead and pause, and then come back and check your solution. All right, let's see how we did. So we have two functions going. Part A, we're plugging in -3 into g. Negative numbers, remember we should always use parentheses with negative numbers, or else you might get a little bit confused. So all my -3's have parentheses. Remember, negative numbers squared with parentheses are always positive. With parentheses, so we're squaring all of -3. So -3 times -3 is 9, right? That's the base. So make sure you don't write -9. And then negative times a negative is a positive 15. All right, and then h of 2, we plug 2 into our h function and simplify. Remember to reduce your fraction. And then finally, no matter what the input looks like, we're going to just replace it with x. So x became 3a, and then we simplified. I wanted to make a note here. A common mistake is to reduce the 9/15 to 3/5, but we're not allowed to reduce or simplify term to term. See how it's part of a difference and a sum? So it's not allowed. We can only reduce when we see one term on the top and one term on the bottom, like we did in the part B. This is allowed. When we see pluses and minuses in between, we're not allowed to reduce, so don't touch it. Okay. Let's look at example 3. This is a little bit different. We're finding x now. So now we're saying in part A, f of x equals 0. So look at f of x, f of x. It's almost like a substitution. So f of x is literally -3x plus 7. And our equation is telling us to set that equal to 0 and then solve for x. So subtract the 7 and divide by -3. Okay, so it's a little bit different. We have a y value essentially, and we're figuring out the x. So part B and C, go ahead and put pause and then come back and see how you did. All right, so for part B, you set the function equal to 6 and you solved, right? So subtracted 7 from both sides, divided by the -3, all right? And then part C is still the same. Even though it's a letter, it's still the same thing. We solve for x by isolating the x. Anything without an x goes to the other side. Divide out by the coefficient. And the only thing here is I moved the negative from the 3 to out front, just like we've seen before. Okay, so now we know how to find function values and x values. Let's look at this. And now we're going to be finding x and y-intercepts, if any. And so this is the function, f of x equals -2. Oy. So the x and y-intercepts. So let's remember, and again, if it's helpful, f of x is a fancy way of writing y. So this is really y equals -2. Well, let's do a quick little graph of y equals -2. That's a horizontal line. Notice there's only one variable. And what's our x-intercepts? No x-intercept. It never comes up here. So no x-intercept. What's the y-intercept? Yes, it's 0, -2. Okay, so that one's more of a conceptual problem. Let's look at one where we're actually doing some more calculations. So part B, g of x equals negative 3/4 x plus a half. All right, so the x-intercept happens when g of x equals 0. And then whatever your x-intercept is, and the y-intercept happens when x equals 0. And so we can think of this as f of 0. B is f of 0. All right, so let's solve that. Let's do this first one. So our x-intercept happens when g of x equals 0. So let's solve that. So g of x is just negative 3/4 x plus 1/2. And now it's 0. Solve for x. Isolate the x. So move the constants to the other side. Subtract 1/2. Okay, now this time we would divide out by the coefficient, but dividing out by fractions is like multiplying by the reciprocal. So make sure the negative comes along, and we're going to multiply by the reciprocal. And notice we do this because this gets us 1. The 3's cancel, the 3 will cancel, the 4's cancel, and the negatives cancel. So this whole thing becomes 1, which is what we want. We want x equals something. So instead of dividing by the fraction, we can multiply by the reciprocal. So x equals, let's see, two negatives make a positive number. You can look at this as 1 times 4 is 4, 2 times 3 is 6, and then reduce it to 2/3. Alternatively, you can reduce as you go, so cancel out that factor of 2. However you slice it, you're going to end up with 2/3. So that's our x-intercept. Let's do our y-intercept. Y-intercept's a little bit easier because we get to plug in 0. So again, that happens when x equals 0. And we can write, whoops, I forgot the function. Is it g? It's g of x. So we're going to do g of 0. And that negative 3/4 times 0 is 0, so we have 1/2. So it's 0, 1/2. All right, so really similar to what we were doing before. Now it's just a different notation. Okay, and finally, we're going to be making predictions. All right, we're going to be making predictions. So here's our example. Despite the No Child Left Behind Act of 2001, students' average math score actually decreased approximately linearly, from 518 points in 2006 to 514 points in 2012. Okay? We are going to predict the average math score in 2017. Okay, so a couple keywords. Linearly means we can do a linear model, and we're going to use these 2 points to create our linear model. Once we have a linear model, we can make predictions. Okay, so our first steps, if we wanted to predict something, our first step would be to find a linear model. So we can actually start predicting. All right, and we're going to use 2 ordered pairs. Let's be smart about this, though. Instead of writing our time, remember, time is normally our input, our independent variable. So instead of writing it like this, let's have t be years since 2006, and then like p or whatever be the score. That way, instead of 2006, we can write 0, 518. That's a lot easier to work with. Okay, so to find our linear model, we're going to use this trick. Let t be years after 2006. And so now our ordered pairs are 0, 5, 18. And 2012 was 6 years after 2006. So we can say 6, 5,000, or 514. Okay, so we have 2 points. To find a linear equation, we have to find the slope. So difference of y over the difference of x. Let's see, 14 minus 18 is negative 4 over 6. And good, our slope is positive, because I said in the problem that it was decreasing. So that makes sense that we have a negative slope. Okay, so let's use our slope. And we have a y-intercept. So now, to make this model, we can do it lickety-split. We can say that this y equals mx plus b, where m is negative 2/3, and b, our y-intercept, is 518. All right? So there we go. And we can make it a function of time using our function notation. Let's say p for points is a function of time. And so we can write it like this if we want. Just time back into our section we're in. All right, but instead of x, let's write t. All right, and then what are we doing with this? Go back to part A. We're doing this predict the average math score in 2017. So what do we have to plug in? How many years after 2006 is 2017? Well, 2017 minus 2006, you can also count on your fingers, is 11. So it's 11 years after. So let's plug in 11. All right, simplify that, and you can do it on your own, but it ends up being 511. I'm going to go back a little bit. That actually starts, so after we have our linear model, now we can do our predictions. So that's the step 2, is predictions. Sorry about that. Okay, there we go, there we go. And then we'd want to state our answer. I'm really going into our space for our next problem, but just to state our answer thoroughly, we would say something like the average math score in 2017 is predicted as 511 points. Okay, so there you go. Now that we have our linear model, part B is going to be a little bit faster. It says predict when the average math score will be 509 points. So key word, we're trying to find when. So this means we have to find our t. All right, and we're given the p-value, how many points? We're given 509 points. Okay, so let's see how we set this up. Feel free to pause it, come back and watch how we should solve it. So here's our p function, and we want to know what's the t when this p function is 509. All right, so let's solve for t. Let's subtract that 518. Remember how we get rid of fraction coefficients? We multiply by the reciprocal. So negative 3/2. Did I say negative reciprocal? I meant just the normal reciprocal. So same sign, please. Okay, so we do it like that because now this cancels to 1, so we just have t over here. And then on our right-hand side, negative times negative is positive. 9 times 3 is 27 over 2. Okay, so this is fine. Let's remember we want to predict when the average math score is going to be 509 points. Let's put this in like a real life situation. So 27 over 2 is 13.5. So 13.5 years after 2006, we're looking at 2019. So in 2019, is when the score will be 509 points.